Okay, so let's look a bit about as I was saying about the SA products, licensing. As I was saying, we're gonna have a shorter day today, and then tomorrow we're gonna continue with the actual installation and configuration of both the ASA software module on the ASA 5515X and Fireside as well, and then do basic configurations of the most commonly used capabilities, and see, look at the logs, look at the GUI, understand the behavior back and forth. So because the ASA with Firepower services still means nowadays both a joint venture between the ASA feature, native ASA features, and ASA with Firepower services. Then what that means is that we still have clearly the ASA features available, which is a very good firewall and VPN concentrator. So routing and switching built in on the box, using of course the native ASA code, which is Repos, PFEAJAR, PBGP. We also Cisco added the zoning support on the SA in the 9 code in order to provide a better ECMP, because back in the days it was impossible to be able to let's say have two default routes facing out on two different let's say interfaces of the SA at the same time. So ECMP was possible, but that was possible only if let's say the default route or the destination for that route was pointing out on the same physical interface but to different next hops. Now you can do proper ECMP through zoning. You have also BGP as a routing protocol supported. You also have PBR supported, which was a feature which was missing from a long time on the SA. So it is a full-blown, let's say, router or so switching capabilities in there. It is clearly a very good stateful layer 2 layer for firewall, which means we can do likewise the regular ACL filtering, where we can have either the interface-based ACL filtering or the global ACL. So pretty much if the traffic would flow to the ASA, let's say like this, from here to here, from PCA to so traffic would flow like this to the ASA from PCA, then technically speaking you can have multiple ACLs configured, which of course it's not a good thing, but still capability speaking, you can have an inbound ACL configured on the ingress interface. You can have a global ACL configured on the SA, and you also can have a outbound ACL configured on the egress interface. Clearly this is not a good design, so ideally you should control traffic either through only the inbound ACL, or in the newer code through the global ACL, and never through the outbound ACL. Doesn't make sense to have three different let's say set of rules in place at the same time for the same traffic. It doesn't add security, it adds complexity, and actually it can decrease the overall security of the device, because it's easier to make mistakes by the fact that you have to deploy the same rule in multiple places on the same device at the same time. So it doesn't make sense. And of course you have identity-based filtering, which what that means, it was a feature added on Cisco a long time ago in the 8 something code. Like for example, when this user connected in here, so on PCA, let's say you have user Christian authenticated, and user Christian was authenticated through Active Directory at the network. So his PC was enrolled in Active Directory, and he has connected to the network. He has authenticated through on the Active Directory controller, which is going to be server A, let's say. So what this means is that then when Christian wants to send traffic in the network, he's going to send traffic to the SA, and then instead of the SA allowing Christians traffic to whatever destination based on Christians' IP address, which I'm going to speak in a couple of why that is not recommended and why Cisco came up with a solution. Then what ESA is going to do, it is going to ask, let's say that PCA's address is .200 in that segment. So Christian in here has an address of 136.1.79.200. So then basically the ESA, it is going to query the AD server, or on the AD server special agent, the CD agent runs. So ASA3 queries that agent, and as the agent, if the IP address of this user that is trying to get access to the ASA, it belongs to any user that got authenticated in Active Directory. And the CD agent is going to reply saying, yes, this is Christian. On that IP address, Christian is Christian authenticated in the network to me, to the domain controller. Then I have learned that that's the IP address of Christian. And then on the ASA, you're going to have firewalls based, instead of based on IP addresses, you're going to have firewalls based on users or based on groups, which was clearly the much more scalable. It was the first version of doing a scalable kind of access control to the device. Because nowadays with the, let's say, IoT concept, like me being Christian, I could have, like, you know, my own laptop, which could be involved in Active Directory. I can have, you know, the company desktop, which is involved in the Active Directory. I could have, you know, the one phone, one tablet, whatever. So maybe I would want to have the same set of access from the laptop and from the desktop, and the same set of access from the tablet, from my tablet and from my iPhone. So what that means is that instead of building rules on the firewall based on the possible IPs I could get on those devices, because also I could be connected from various portions of the network. I may be connected from the headquarters. I may be connected from the VPN. I may be connected from, you know, remote sites. So it becomes totally unscalable to control access out on the internet, or out on the internet to and from the internet, or to, you know, servers in the data centers by configuring rules based on IP addresses. Because the user has a lot of devices, has, you know, a lot of IPs, because he connects from multiple places, he gets assigned different IPs, so it becomes unscalable and doesn't make sense to, you know, build 20 rules for the same user just because he gets different IP addresses. So ideally, it's way better to to say that you provide access to Christian to, let's say, the internet, or to specific data center servers, regardless of whatever the IP address is of Christian. And this was the first variation that Cisco added on the firewall, which also other vendors added on their firewalls to allow scalability and, you know, manageable security, access control lists, and also to actually increase the security, not decrease it. Because the more IPs you have to control, the more susceptible you are to you know, configuring wrong access lists in there and providing more access than it's actually required. But of course, then Cisco came up with the SGT on the firewall, security group tagging, classification, and enforcement, which is supported only on the ASA-X series, not on the ASA regular series, because SGT requires, it could require both hardware support and also, of course, software support. What SGT is, it started as a layer 2 tag, and then it came in the end as a layer 3 tag. So for example, if you would have this user in here, Christian, authenticated to the network, so as he connects to the switch, he would be authenticated from ICE, for example. Let's suppose that for this server is ICE, and as ICE authenticated Christian, then it would push back to Christian a security group tag, which basically the SGT tag would be a contextual tag based on, like, from where does Christian access the network? Is it from VPN, from Wi-Fi, from wireless, from which location, from which device, at which point? And based on all of those criteria, Christian may get a tag of 9 or a tag of 10 or a tag of 12 or a tag of whatever, but it's completely independent of the IP. Because not only the IPs become unmanageable to create a lot of rules for Christian, which may have 20 IPs allocated in different places, but also you would want to actually create access firewall rules based on time of the day Christian is connected to the network, or location, or type of device, or posture status of the device. So clearly you would want to make smarter decisions to allow Christian access in the network, not solely based on is he authenticated and from which IP, and that's it. It's not only unscalable the old way, but it actually doesn't provide the required security for nowadays networks. So based on all of those criteria, which are called context, ICE is going to push not to Christian's PC. It's going to push a tag. It's going to allocate a tag to Christian, SGT tag, let's say 25. And then as Christian would send traffic in the network, which is regular traffic, regular IP traffic, so IP traffic, then what happens, the layer 2 switch connected to where the Christian is connected to, or the wireless LAN controller, or the VPN gateway, it is going to attach to the IP traffic initially at layer 2, and nowadays also it can do that at layer 3 via different mechanisms. It is going to push this tag that ICE has assigned to Christian, is going to copy that tag in the layer 2 header or in the layer 3 header. And in the end, the overall scope of this capability being that you'd go on an enforcement device, which can be anywhere in the network, at the egress point of the internet, or at the data center level, and you would say that, for example, SGT tag of 25, which that's Christian from being connected at 9 a.m. in the morning from its company desktop, and its posture status is okay, he's not infected. I allow traffic from SGT traffic 25 to, let's say, SGT traffic to tag number whatever 30, to SGT number 30, which that is a FTP server in the company, whatever. So it's clearly way better to provide this kind of contextual access based on state of the device, state of the user, time of access, based on health compliance of the user and authentication status of the user, and not based on IPs. So clearly now identity-based firewall on Cisco was just like a transition mechanism. Nowadays, ideally you would want to do SGT, access control enforcement, and the ASA firewall supports those capabilities. Okay, so clearly it's way better to provide, because as I was saying, one of the requirements of the definitions of the next generation firewall would be to be able to provide better network segmentation and better user control and device control to and from the network, and not solely based on IP addresses. And with SGT you can also do, because for example, why SGT is clearly a good thing is, for example, let's say that in this VLAN, and this is a Cisco proprietary feature, let's say in this VLAN at 79 you have multiple users connected. You may also have user PCB in here, PCB, another PC, let's say PCC in here, connected, multiple PCs. So what happens is that, for example, let's say that PCA gets infected with whatever malware. So PCA gets infected with some kind of malware. Until the time that, when speaking a couple, you have, let's say, the network detects that somehow that this PC got infected and is going to quarantine the PC dynamically. You would clearly want PCA not being able to infect anyone else in the network, including this host connected to the same VLAN. This is what is called in industry as lateral movement, where the fastest way for infection to spread is within the same VLAN, because it's rarely that you have some kind of security in place to be able to restrict traffic within the same VLAN from the users. But by doing that authorization and that tagging of the user's traffic with SGTs, you can clearly say that PCC would get an SGT tag of 50, for example, because he's not a kind of user. So PCC would get a tag of 50, let's say. Assigned from ICE, PCA would get a tag of 40 and PCB a tag of 30, which clearly means that you wouldn't allow, you can configure that also on the switch, so that the switch doesn't allow traffic back and forth between tag 50, tag 40, or tag 50 and tag 30, for example. So that means that the lateral movement is being stopped instantly, so the infected PC, it's not gonna be able to infect other PCs either in the same VLAN. Then we have the advanced VPN features, which the ASA is a full-blown capable VPN concentrator, supports IPsec, both IPv1 and IPv2. Clearly nowadays IPv2 for a lot of reasons is way better, and SSL VPN both client-based via the AnyConnect client and clientless via a clear browser web portal. And likewise AnyConnect supports both SSL client-based and IPv2 IPsec client-based. And of course the regular ASA advanced NAT capabilities, static dynamic NAT and PAT. And of course single, double NAT, and also policy NAT. So you have a lot of extended capabilities on ASA firewall from the NAT point of view. Now, as added to that, we add the source firewall with the Firewall capabilities for the next generation firewall, where we have the what I call the NGIPS, next generation IPS, which is nothing else but an IPS, which of course is also based on server signatures, but is also context-driven threat detection and mitigation mechanism. So it also is behavioral based. It's not only based on simple signatures. It is much more than that. We're going to speak about that probably in the advanced part of the firewall services. Something else which is clearly a must nowadays is application and micro application control, because not only you need, so with the SGT you have proper control. You define, you assign a tag to the users contextually speaking, and then you can control that. You can control the user's traffic in the network also based on SGTs on the destination. So as I was saying, you can basically say that you can define in your network on ISA policy which states that in your network the FTP servers have a tag of 90, the web servers whatever have a tag of 100, the AD servers a tag of 99, whatever. So you can control clear traffic very good, very securely from the users, from the devices towards the internal network services, because a tag is going to define like a socket. It's going to define both, the context of the user, also is going to identify the IP of the user, and also the services of the destination that the user is trying to reach out there. But clearly one problem is when you want to control traffic out on the internet. So if like you would want to control traffic, again PCA, users being Christian, he's been assigned an SGT tag or not, doesn't matter. You want to control where Christian can go out on the internet. And for example, doing a URL filtering, saying I'm going to allow, I don't know, google.com, let's say, I'm going to allow facebook.com, for example, right? So let's say I allow facebook.com to Christian based on URL filtering. This is from long time ago, no longer enough. Because on Facebook, Christian can do a lot of things. He can, of course, chat. He can do upload, download the files. So by uploading, he could leak data from the network. From downloading, he could bring in malware on the endpoint. He could do, audio, video calls, which is of course something that you may not want to allow for a lot of security reasons. And all of those are being contained in the URL filter which says allow access from Christian to facebook.com. So for that specific reason, you would want to, if you allowed access to Facebook, you would want to allow access to Facebook only chatting. So you don't want to allow to access to Facebook to download or upload, or to do audio or video sessions through Facebook Messenger, for example. So for this reason, you need true application support, and not only application support but micro application support. So the firewall has to be able to identify, okay, Christian goes out to Facebook, but what service is he using from Facebook? Is he doing video sessions? Is he doing audio sessions? Is he downloading? Is he only chatting? Is he posting? What is Christian doing? Because you would want to restrict some services and allow other services, and you would want to. I just gave the Facebook example, but this applies to a lot of other things. Like you would allow access to, for example, to stargoogle.com, for example. So whatever is that google.com, but this also could mean a lot of other unneeded services, like Gmail. This could mean also YouTube in some cases. This could mean regular Google. So you would want to likewise restrict that. For example, you want to allow access to Christian to Google to only do searching and nothing else. So for this kind of capabilities which are required nowadays, you need true application support and also clearly micro application support. So allow access to a specific application, but to what kind of micro application within the main one. And of course, as somebody stated before, the challenge with this kind of this kind of traffic, with this kind of limitation, is that most of the traffic, a lot of traffic nowadays, is being secured through SSL. So in order to actually be able to provide DPI, you need to do SSL decryption. You are able to do URL filtering not only based on the certificate, but based on what they call the SNI value. So in an HTTPS session, we have something which is called SNI, Secure Name Identification, I think it is, which basically in that field of the HTTPS session, which is visible in clear text, you're gonna find the actual URL that the user tries to access. Like for example, it's gonna be an SSL session to www.google.com, for example. So in that field, you actually see where is the user going to the exact URL by looking in that specific field in the HTTPS session, which is visible in clear text. So you would know if Christian is going to Facebook, you know if Christian is going to Google, to whatever else, but that's everything you know. You don't know exactly what services is Christian accessing from those URLs. So for this example, as somebody was saying before, you clearly need your next-generation firewall to support SSL decryption, real time, clearly without creating a bottleneck from the performance point of view, because only by opening the encrypted session, you actually can see what is Christian doing on Facebook. Is he chatting? Is he doing video? Is he downloading? Is he uploading? Is he allowed to do that or not? So what's going to end up happening at that point is that the user, of course, from the user's point of view, is going to be transparent. If you configure properly, the user is going to have like an SSL session or TLS session with the firewall, SSL or TLS. The firewall decrypts that session, looks inside the session, see what is exactly Christian doing on Facebook, and if the traffic is allowed, then the ASA has a different SSL TLS session with the actual destination, which was Facebook or Google, whatever. So the ASA is going to see the clear text traffic. You have two. It acts like a man in the middle in there, MITM. It decrypts the traffic in real time in order to be able to see exactly which micro applications is Christian using from Facebook or from Google or from whatever. Of course, you need your filtering likewise. As another set of basic control, because clearly, for example, it doesn't make sense that, let's say, you would want to drop all Facebook access. it's clearly way better to just drop all traffic that goes to facebook.com to start.facebook.com, and the ASA is gonna the firepower module is gonna do an instant drop of the traffic without doing any kind of DPI. Is way better to do this rather than going and doing it this at the application level, saying if application is Facebook, then drop all micro applications. So you would want the ESA to drop the traffic, the firepower service to drop the traffic as fast as possible, with the less amount of resources being consumed to drop that traffic. It's clearly way better. For that, for the same reason, you have two types of URL filterings. So you have dynamic based on reputation filtering. So like if the resource Christian is trying to access has a low score, which is configurable, of course, has a very low score, then you would want to drop the session instantly. Other than, it doesn't make sense to if the destination is clearly a malware infected site based on reputation, doesn't make sense to just send the traffic out there, and then when the traffic returns from that specific host on the internet, the firepower service to inspect it and drop the malware. It doesn't make sense to consume all of those resources back and forth. So that's the one way of doing it. And of course, the second way, both of them are available at the same time. It is static based on configure rules. So you're gonna do URL filtering based on the reputation of the destination, and also of course based on your configure internal policies, which, let's say in your company, you wouldn't want to allow traffic destined to, I don't know, Facebook or what else, to Instagram, between certain hours or in general at all. So that's going to be a statically configured URL filtering. So for basic URL filtering, you don't need application visibility and control, because as I was saying, regardless of the session type, if it's HTTP clear text or HTTPS, which is encrypted, you still can still identify. You have enough, let's say, clear text data in the session's header in order to identify what is the destination URL the user is trying to access, and if that's being allowed or not, based on the reputation of the destination or based on the statically configured URL filtering policies based on your company internal rules. But then once you pass that mark of is the traffic allowed or not by URL filtering, as I was saying, you want to, if traffic is allowed, you would want to decrypt the session and do application inspection, deep packet inspection, to see, okay, if I allow traffic to Facebook, then what kind of traffic do I allow to Facebook? And then of course we have advanced malware protection, or malware protection, of course, from other vendors, but Cisco is called advanced malware protection, which is going to be nothing else but advanced sandboxing, which performs both static and dynamic file analysis. So static, what that means is that, for example, so again, Christian wants to send traffic in the internet to a host which to a destination which hosts malware. And let's take use case number one, where malware is known by Cisco's intelligence, by Cisco, Talos, and ThreatGrid. So as Christian goes out on the internet and does a download of a infected file, for which the cloud on Cisco knows that's it's malware. So when traffic returns with the downloaded file, DSA is going to send that traffic to Firewall for inspection. And of course, we're going to speak exactly how that works, but we're going to send that traffic in the cloud for inspection, for sandboxing. And state number one, when so option number one, when malware is known, it means it's going to match in the cloud on a MD5, or actually not MD5, it's going to match on a SHA signature, which the cloud is gonna know instantly that, hey, this is known malware. So it's gonna return instantly to Firepower saying this is malware. So that means that the ASA is gonna drop the session instantly, in order for the endpoint not to get infected. But option number 2 clearly would mean that, following the same approach where the user goes out on the internet, when the cloud is being queried, so option number 2, when the cloud is being queried, we're not exactly sure if that's malware or not. So we're going to get a response from the cloud saying unknown. Or what the cloud could do, of course, either it's going to be unknown, either if it was not known to begin with, it didn't have it didn't match a signature, still the cloud could mark that file as a threat, as a malware, and send likewise the reply back to the Firepower in order to drop the traffic in there.